Hello, welcome to this DTS demonstration video in which we'll show you how easy it is to invoke behavior in between small world sessions all via DTS. The small world sessions can be of the same version or, as is the case with this demonstration, they can be of different versions. Here we are in a small world PNI 5 session. We have the DTS product loaded and we are ready to go. We will configure 3 procedures that will allow you to investigate the underground routes from a small world PNI 4.3 session. Here is the glue file that allows us to configure the 3 procedures. First procedure is a simple count of all the underground routes in the database. It doesn't require any parameters and returns an integer. We make this procedure available by invoking DTS managers register API call. This call requires a few parameters that allows us to describe the procedure we want to expose together with its parameters and return types. In this case, we specify how the procedure will be known to the DTS clients and also describe the return types, which in our case is an integer. The second procedure is a bit more complex. This performs a spatial search for underground routes in an area given as a parameter, and it returns the IDs of the underground routes in the given area as a vector of IDs. It also requires a second parameter that represents the maximum number of IDs returned. Again, we make this procedure available by invoking DTS Manager's register API call. As you can see, we also describe here the parameters that the procedure requires by providing a type and the name by which to be identified. Notice also the return type is specified as being a vector. The third procedure returns the underground route details for a given underground route ID. The details are embedded in a custom record exemplar defined explicitly for this call. The record exemplar has 2 slots, one for the underground route attribute values, the other is for the details regarding the cables inside the underground route. As you can see, for the cable details, we construct an additional record exemplar. However, for the underground route info, we use the data store record exemplar and specify only the fields we want to expose. Since we are using complex types for this procedure, we have to make those types known to the DTS system. We do this by invoking DTS Manager's register type method, in which we specify the key for the new type, the record exemplar, and a vector with slot descriptions. In this case, the type of the slot and if it's a vector or not. Notice that for the underground route, we only specified the names of the fields we want exposed and did not provide any information regarding the types, since that is already contained in the data dictionary. After the underground route and cable info types have been registered, we can register the type of the result for the procedure call using the same mechanism. This time, the type is using 2 complex types that we registered earlier, so we only have to provide the keys we used to register those types. Notice we are using the same string used as the key when we registered the new record exemplar. Last step in this setup is to register the third procedure with DTS, again by invoking DTS Manager's register API call. This time we specify the procedure requires an integer as a parameter for the root ID, and for the return type we specify the key used to register the new record exemplar that embeds the underground route details and the cable details. So these are the 3 procedures we want to make available in an external client, which happens to be another small world session, but it can also be Java or .NET or a web service client. For this video, we created 3 procedures, but in reality, we can invoke existing procedures or methods. It is only a matter of describing the types. Now let's load this glue file and instruct the DTS manager to start as a producer serving metadata in order to build the DTS project we will use. Here are some environment variables we will use to instruct the small world session how to connect to the DTS system. After we load this, we can start the DTS manager as a producer. We are now ready to build the project. Let's move over to the DTS Web GUI in order to do that. When accessing the DTS Web GUI, you are presented with a login page. After logging in, you will see all the available DTS projects for your user. For this demonstration, we will create a new project called test_SW_CFG. Wherever you see the light bulb icon, you can click on it to get a short summary of the resource. For the project, we can see that there are no connectors yet, so let's add one. Let's name it test-PNI and choose its type SmallWorld PNI5. We also need to tell the SmallWorld connector what view and alternative it needs to target. Then we can add the connector to the project. As an appropriate connector is currently running, DTS has already extracted all the available collections and functions and is showing them in the middle column. This will contain all usable collections for the specified view and alternative, as well as all the methods and procedures currently registered with the DTS connector SmallWorld session. Collections and methods can be filtered by keywords using the text field at the top of the column. Since our project only needs to handle procedures, we will filter out the collections. The first method is our underground root counting method. It returns a single result. Next, we see a procedure that finds roots in a given area. Finally, we have a procedure that gives us customized details about an underground route. To make these procedures available to clients via DTS, we simply have to click all the checkmarks for each one. There is one final step. In order for the project to start working, we have to publish it. Now let's take a look at how the DTS SmallWorld client can access the procedures. Now we are in SmallWorld 4.3.0 with the DTS Magic product loaded and these two environment variables set. Nothing else is needed. To connect to DTS as a client, we run the activate consumer command with the DTS project name as the only parameter. We are now connected to DTS. Let's see what we have access to. The first thing we can find is our PNI5 connector, which we named test-PNI. Let's store it in a PNI5 variable. We can then list the functions it exposes, the three functions we registered in the project. We will create a handle for the counter function and execute it. As you can see, this returns a result of 735 underground routes in the PNI5 data store. Next, we create a handle for the underground route finder method. This function requires two parameters. The first is the search area, which we define here as a rectangle. The second is the maximum number of results we want to get. We can use the number 12. Now we can execute the function and print the resulting underground route IDs. Our last procedure is the underground route detail getter. We pick up a handle on it and execute it for the first ID in our previous result. The result is a uroute info object that looks like this. It also includes an actual underground route record, complete with the route geometry. Finally, we can also take a look at the cable information our procedure bundles in the details package. Thank you for your time.